Let's use our exponent rules to multiply. Problem 1a. We are multiplying the two terms negative 3x to the fifth y to the fourth times positive 7xy squared. Step 1. Multiply the coefficients. Here we are just going to handle the number part of our multiplication. Negative 3 times positive 7 equals negative 21. Step 2. Multiply variables with the same base using the product rule. X to the fifth power times x. If you see a variable that does not show a power quantity, then that means that that value is 1. X to the fifth power times x to the first power, and using the product rule, we add those powers. 5 plus 1 equals 6, x to the sixth power. Y to the fourth power times y to the second power gives us y to the 4 plus 2, which is y to the sixth power. How did we use the product rule? We use the product rule when multiplying variables together that have the same base. And using the product rule, we add those powers, x to the fifth times x to the first, and y to the fourth times y to the second. Problem 1b. Step 1. Multiply coefficients. Here there are no values that we see in the multiplication of the coefficients because the coefficients are all just positive 1. So we can go straight into step number 2. Multiply variables with the same base using the product rule. In these three expressions, we have 3 times where we have the same base of the variable x. X to the fifth power, x to the first power, and x to the second power. We can use the product rule, add all the powers, x to the 5 plus 1 plus 2, x to the 8th power. The next matching variable base is y to the third power, y to the 7th power, and y to the first power. Will give us y to the 3 plus 7 plus 1, which equals 11, y to the 11th power. And the final base is the variable z, and there are no other matching bases, so the final part of our multiplication is z to the third power. How did we use the product rule? We use the product rule by adding all of the powers when we're multiplying with the same bases. You are now ready to use exponent rules to multiply for problem 2a and 2b.